Good morning, children. We are discussing in this unit about basic things of physics, measurement, and lot of accurate values, how to measure, so the things discussed. And in last few classes, we are discussing how to measure the height and what are the methods are adopting. So about that we are discussing. And today we will start the class with radar method. So this radar, it stands radio detection and ranging. This radio detection ranging is used to measure accurate distance. Even we can measure up to the nearby planet like Mars, Moon, etc. By measuring the time interval t, the instance of radio waves, we having the instrument. In the instrument itself, it is acting like a sender and receiver. Sender is also called as transmitter, and receiver will receive that wave. After receiving that, we can calculate the distance of that planet. Here we'll see how to calculate that. And here there is suppose we are sending the rays radar towards any planet, and suppose this is the point of transmitter, this is the point of receiver, say this is the planet. We are sending the rays from the transmitter towards the planet. It travels for the distance d. In this itself, it is acting like a receiver. After falling on that planet, that radiation will come back, it will be reached to the receiver point. Now once again it is traveling for the distance d. Okay, so from transmitter to that planet, then planet to receiver, this radar is traveling for two distance, and it is traveling for the distance 2d. Then we can do the calculation. Now the distance is what? 2d. Then we can use the velocity formula. Velocity v is equal to d by t. This is the formula we know very well. In lower class we studied about this. Velocity is equal to distance by time taken. And now here for this radar, the distance will be taken as 2d. So that we can substitute here as v is equal to 2d divided by t, and this radar is traveling with the speed of light. Then we can substitute that value. We need to find out the d value from this. Then we can write the formula d is equal to vt divided by 2. This is the formula here we are having to find out the distance. So after transmitting and receiving, the timer will show the time, how much time that radiation is traveling. That we can substitute here as t. Then v, we know the speed of the radar, we can substitute the velocity of light. Then after substituting all these value, when we are solving that, we can find out the distance between our earth versus other planet. So that are calculated here. This is the method we are using in this radar. In figure 3.16, it's showing the method of radar method. So what I explained in previous part, this antenna itself is acting as transmitter as well as receiver. So first we will send the waves towards any target. Even we can calculate the height of the flight where it is flying, and after that if it is falling on the aeroplane means that same ray will be reflected back. Then receiver receiving that, and here knowing the time t, we can calculate the distance between the transmitter to that particular target. Even we can calculate the mountain while traveling on a ship, and when we are in aeroplane we can find out the opponent target, etc, etc. For many things we can use this method. This is called as radar method. This is important method, and for this you can mark the answer. Full topic from radar method up to this diagram you can mark the diagram, you can draw. So like whatever the object, not only it's not compulsion for aeroplane alone, you can draw any object. Okay, have you understood about this radar method? Yes, fine. Next is example 1.3. So last one is explain about radar method. Okay, write that question. And here example 1.3. See the question. A radar signal is beamed towards a planet and its echo is received in 7 minutes. A radar signal is beamed towards the planet. It is received by 7 minutes. If the distance between the planet and Earth is 6.3 × 10^10 meter, calculate the speed of the signal. So first we will write the given data. Distance is given, then time is given 7 minutes, then have to convert into seconds, 7 into 60 seconds. Then speed of the light we are calculating, speed of the distance we are calculating. Here the question is speed of the signal. Then we can substitute v is equal to 2d by t. Then substitution 2 into 6.3 into 10 power 10 divided by 7 into 60. After solving that, we are getting the answer as 3 into 10 power 8. Students, you can solve this. If you have any difficulty, you can ask question through WhatsApp. And the answer for the speed of this signal. And next is some range values are given. Range and order of lengths, size of the object and distance and its length are given. The distance to the boundary of observable universe is 10 power 26 and Andromeda galaxy is 10 power 22. Size of our galaxy 10 power 21. Distance from Earth to the nearest star 10 power 16 and thickness of a paper and wavelength of light up to diameter of proton it is given. You have to thorough this. You have to thorough this approximate value. And then figure 1.7, the instrument already what we discussed for 1 kg platinum iridium cylinder is shown in this figure. And next some values, some common practical units: Fermi, angstrom, nanometer, micron, parsec, everything is given. So which we studied in 9th standard itself. Then do you know why is the cylinder used defining kilogram made up of platinum iridium alloy? So this is because it is least affected by environment and time. The shape, the size will never affected. The effect of this shape is very less. That's why they are using this cylindrical. Then one CSL Chandrasekhar limit value is 1.4 times of the mass of the sun. The smallest particle unit of time is shake. 1 shake is equal to 10 power minus 8 seconds. So these constant values are given. Just you thorough this, and this value may be useful in your upcoming either entrance exam and some other preparation. You can use these values. Next, measurement of mass. So about mass we discussed in you may study in lower class, and here about the mass it is given. First we'll see what is mass. Mass is nothing but mass of a body is defined as the quantity of matter contained in a body. So in a given body, so how much quantity of matter is there, that is called as mass. The SI unit of mass is kg. Okay, so about this definition we know, and this mass will never affect by temperature, pressure and other things. It is always constant. If the object is going to some other planet, if it is some other place, means this value will never affect. This is called as mass. And some range of masses are given. Electron, its value in the range of 10 power minus 30. Proton or neutron 10 power minus 27. Uranium atom is 10 power minus 25. Then dust particle 10 power minus 9. Raindrop 10 power minus 6. Mosquito 10 power minus 5. Milky Way galaxy 10 power 41. Observable universe 10 power 55. These values are given here. So these are all some ranges, range of mass. And some of the weighing balance commonly used are common balance, spring balance, electronic balance, etc. In subs and all we are using electronic balance. It's showing the accurate value. Even in fraction values also it is given as accurately. And next is measurement of time intervals. So where we are using time? For everything we are following the time. So morning wake up and school period wise, and exam timing timetable, and if you are going to traveling train, aeroplane, there is also time. So everywhere we are using the time. So here we will see about time. A clock is used to measure the time interval. An atomic standard is working based on the periodic vibration, and this periodic vibration which is produced with CCM. And some other clocks are electronic oscillators, solar clock, quartz clock, atomic clock, decay of elementary particles, radioactive dating. These are the clocks we are using. And in this figure 1.8, atomic clock figure is given. And dear children, you can mark in this measurement of mass, in this topic, from mass of your body till its SI unit of mass is kilogram. So up to here you can mark question define mass. Then in measurement of clock, so in these different types of clock you can mark uh, electric oscillator up to radioactive dating, etc., up to that the different types of time intervals. Okay, so different type of clocks you can mark in this. And after that, order of time intervals, the lifespan of most unstable particle is 10 power minus 24, period of X-ray is 10 power minus 19, then period of radio is 10 power minus 6, up to age of universe 10 power 17 are given. These are all some important values. These values are given in 10 powers. You have to thorough this, all constant values. Hope all you will thorough that constant values. So just to thorough with you. So this thorough values will give more helpful. It will give more helpful in other entrance examinations. Next topic will move to theory of errors. This theory of errors. First we'll see what is called error. If we are doing any experiment, in that experiment some uncertain values are there. So what is there? Some uncertain values are there. That uncertainty is compared with some standard value. So uncertainty with the standard value, that uncertainty is nothing but a error. We are saying that in a term of error. And any calculation, there are more chances for error. That error may occur due to various reasons. Due to the various reasons it may acquire. What are the reasons? So how we can rectify that? Whether this error is unavoidable. So for everything we'll discuss in later topics. And here the statement about error, it is nothing but uncertain. The uncertain is called as error. And so to avoid that, that should be compared with the accurate standard value. So have to find out how much difference between that. Then we have to write the correct value for perfect practical experiment. And here there is a, do you know, India, the national laboratory has the responsibility of maintenance and improvement of physical standards of length, mass and time. And in this theory of errors, you can mark the answer from here up to here. So what is called error? You can write this answer. Okay. And next is accuracy and precision. So accuracy means it is exactly. So where we are planning. So what is our targeting? We are achieving that target exactly means that is called as accuracy. And precision means we are doing something, it is not exact on our target, but all our attempts are closer to each other. This is called as precision. Okay, and say the height of the person is 5 feet and 9 inch, and but by mistaken somebody measure his height is 5 feet, but later the accurate is 5 feet and 9 inch, and here the difference is 9 inch. This is called as error. Okay, so what he has to measure 5 feet 9 inches accurate. And if the measurement is precise, if it is accurate means it is if the measurement is precise, it is not compulsory, it should be accurate. So there are some different, and for that we having a figure 1.9. In this figure you see the first one, A. This pink color is our bull eye. So our target is that pink color, that mid portion, and we are shooting on this plate. So 4 bullets are fired, and see that 4 bullets are scattered almost around the pink. And here it is not accurate. We did not shoot at the midpoint. At the same time, these 4 are different to each other. So no accurate, no precision. And see B, we are shooting that the pink color is not targeted here, and no bullet is on pink, and it is not accurate. At the same time, all the bullet marks are near to each other, then we can say it is precise. And see the picture 3, target is fixed, the bullet is fired on target. At the same time, all the 4 bullets are closer to, so all 4 bullets are fall on target. So we can say this is accurate plus precision. So first one, the target is not done and all the 4 bullets are different places, so no precision, no accurate. And B, the target is not done here, so no accurate, but all the 4 are very close. So here the target is not achieved, but all the 4 bullets are close to each other, then it is called as precise. And see the third picture, it is on target, all the 4 are close to each other, we can say it is accurate and precision. So this is the example is given for accuracy and precision. Okay, and these 3 are given, and this is visual example. And here one example is given, a numerical example for accuracy and precision. So dear children, just you go through this paragraph, this example, so you will understand by yourself. So all the precision is not compulsory for accurate. Some cases it may be with accuracy. Okay, so that we are understanding here. So I hope you all understood what is precision accuracy. Okay, now you mark answer. Full topic accuracy and precision from that point to end of is more precise. Okay, including that figure 1.9. This is important 5-mark question. So please note down with example. And for today's homework, you can write radar method and following that sum. After radar method, there is a example sum is given. So you discuss, you study, you thorough that 2 questions. Then without seeing that, you write in your classwork, homework note, homework part. Then take photograph, send to me, my personal WhatsApp number. Okay, and rest of the topics we will discuss in next class. Thank you, children.